Welcome to MIS 437 Data Mining and Warehousing, Module 3. In Module 3, we look at the data warehouse. There are a few key concepts to the data warehouse you need to be familiar with. First, we'll look at the data warehouse compared to the data store or data mart, as it's often called. We also need to look at how the data is actually stored, the architecture of the storage mechanism. The two major database architectures are the relational database and the multidimensional database. We will compare and contrast those. And since this class focuses much of its time on the data itself, we will also talk briefly about how we get data into and out of the database, namely OLTP, or Online Transaction Processing, and OLAP, Online Analytical Processing. So let's look at where we store the data. I'm going to start with the bottom of this slide first. The Data Mart is a repository of data stored for the use of one community. This may be a specific department, say the HR database maybe, or maybe a small business's inventory management system. The Data Mart generally has one focus: store data so users can get data in and out with little to no difficulty. The data warehouse, on the other hand, can be viewed as a collection of data marts. Although not always the case, it can be helpful to think of it that way. Other than sheer volume, the major difference between a data warehouse and a data mart is that the warehouse is built from an organizational perspective. The result is that retrieving data from the warehouse can be complicated and often requires contracted experts to manipulate. It is important to note that in today's computing environment, we have moved away from physical boundaries. It is no longer useful to think of these in terms of physical location. There is no real distinction between where things are stored and how we move data in and out of those locations. The virtual world has effectively changed all that. As mentioned previously, storage architectures come in two flavors: relational databases with its traditional columns and rows, and multi-dimensional databases, which stores data in something called cubes. Looking at the relational database, we see it is a two-dimensional database consisting of rows and columns, and the values are stored in the fields at the intersection of those rows and columns. Relational databases make use of tables to store data in different formats and use key values in each table to link those tables together. This can make for some very complex and therefore very slow queries to retrieve data from them. There's also quite a lot of duplication required in the tables to represent multiple results. For instance, look at the table on the slide and note that because each student takes more than one course, 2 rows are required for each student to enter grades. On the other hand, multi-dimensional databases use a concept called data cubes to house values on more than 2 dimensions. Representing effectively the same values from the previous slide, the multi-dimensional cube would look something like this. Notice that instead of a single x-axis and y-axis, we have multiples of each, as well as a z-axis adding depth to the cube. We can now compute the results in a variety of ways. For instance, to see a comparison for grades for a given course by instructor, we simply need to look at the x-axis for that course. This gives us much more efficiency. The design also lends itself very well to OLAP applications. Lastly, let's define 2 terms widely used for getting data in and out of the database: OLTP, or Online Transactional Processing, defines the means for populating our database. It is functionally designed around operational data. Its primary reason for existence is to facilitate doing business at the transaction level. It's designed for high volumes of transactions. OLAP, or online analytical processing, on the other hand, is designed around data retrieval. Focused mainly on planning and problem solving, it is designed with a low volume of transactions in mind and is often comprised of data retrieved from OLTP-based systems like data marts.